Alex, we've talked
Yes,
about a
sir.
lot of very dangerous things on the show.
That we have.
And I was talking to my brother, and he brought up the very good question of what is the most deadly animal in terms of danger per to size?
Danger to size. I mean, if we're gonna go just pure like animal as the most generic definition, I'd have to say like the flea, but that's really something you can't see. I mean, because you think like the Black Death and
Yeah.
everything, all the diseases, like there's a lot of invertebrates that will mess you up. But if we're going like we'll stick to like tetrapods, like something you can
Yeah,
see.
tetrapods, vertebrae, things like that.
I mean, it's pretty much related. I gotta go with like rats because they're what carries all those fleas and stuff that just spread all that disease. So I mean, they're just the vector. Like they're just what carries the thing that makes the disease. But I mean, if it wasn't for them, it would. Like, had they not done it backwards during the Black Death and actually killed the rats instead of getting rid of like I think didn't they get rid of like a bunch of the cat? They thought it was the cats and things
I
like the
I don't
wild,
remember.
like the like the feral animals in the streets of like
Hmm.
London or whatever. They killed a bunch of them, letting the rat population just go crazy, which made it worse. Um, but other than that, but then you got to go for like if you have to relate it to how deadly it could be versus it actually is, because like cows, people are around cows a lot,
Yeah.
or I have a better one. Like cows, just because people are around them, like on farms and stuff. But you know what it is, at least in America, the white-tailed deer. The amount of people that will hit deer and wreck.
That's fair. But
That's we've had.
but they're big though. So danger to
I
size is
I
like,
know, but
but there's still a lot
the
of danger from them.
yeah. I mean, they're not as big as people think though. Like a really big one is like 200 pounds.
Yeah, true.
Like size wise, like they're like similar to me as far at least like weight and like overall
Right.
body mass. I mean, they may be a little thicker just because of the way they're built versus the way people are built, but they're not like a live weight like 200 pounds, 160 to two. We'll say like 160 like 230 is like a decent range. I don't know. Let me do a quick little
See,
Google.
because I went the opposite direction, and I went more for like poison and venom. So I had the stonefish in my head.
Mm-hmm.
Because that's
Stonefish is a good one.
small. It's like it's a nice little package, and they cause a lot of pain and death and things of that nature. And we can't use the irukandji or the box jelly or even the
Yeah.
blue ringed octopus or stingrays, and those are all dangerous things. The ocean has a lot of dangerous things.
So, yeah, it gets real crazy. So here we go. Your average summer weight is so like an adult male and contrary to what it usually is, they're actually larger the farther you get away from the equator, which I'm guessing probably has to do because they put more fat on for the wintertime. Um, a good sized male can get up to 300 pounds, with the record being 400 pounds in like Minnesota and like Canada.
Yeah, have fun
But
dragging that one out.
yeah, exactly. But your average, the records is there was a deer in Minnesota that was this is field dressed, 403 pounds. I mean, that is, that's hefty.
Right.
So they're thinking alive, it was like 5'11". Now that was probably like a ranch deer, like a fence deer.
Yeah,
But
one of
you're
those one of those trophy deer that is farm
yeah,
fed for their entire life.
basically, yeah, corn fed. But your average summer weight is like for a male is about 150, so like 68 kilos, and for a female is about 100, about 45 kilos. So human size ish. So it's I wouldn't say they're super like weight size, because I think you hit one of those, it destroys a car.
Yeah, and probably
If
people
you hit
inside
it
of
at
it.
speed,
Yeah,
yeah. Usually
but
the
that's
deer doesn't fare as well either, but that's besides the point.
I like this topic. That was a good topic to have.
It was.
But as always, this is Alex. I'm Tyler. Welcome to Life: The Complete Story. Before we start, make sure to follow us on our socials at Life Complete Story. Oh, my bad. Life Complete Story on TikTok and Instagram. Life the Complete Story on Facebook, YouTube, Spotify, and wherever you get your podcasts. And if you have anything you want us to talk about, email us at lifecompletstory@gmail.com. And Alex, we'll start how we always start with our nature in the news.
Yes, sir. Let me bring it up. So today we are talking about a little bit of succession.
Yeah, it's been kind of the theme for the past couple weeks.
Yeah, so this was published just a few days ago from, I'm not even going to attempt to pronounce that source name because I will absolutely butcher it, but it is...
We're talking like Iceland region here.
Yeah. The title of the article is Birds, Not Wind, Brought Life to Iceland's Youngest Island. So this island called Surtsey, Surtsey, kind of from the lava flow, because if you don't know, Iceland is a volcanic island small chain, right?
Yeah.
Yeah. Volcanic island chain in the northern Atlantic. This island erupted in 1963, so relatively recent. But now scientists have noticed that there are plants colonizing the island, and they have figured out that they were brought there not by the wind or like ocean current, but actually by the birds that have flown to the island, like your long flying ocean going birds, like your gulls, geese, shorebirds. And that's pretty cool. Something that, not so much puffins, maybe an albatross.
Yeah.
So this is something that we don't really get to see in action a whole lot, especially within recorded history, where something like this is an example of what we talked about. This is primary succession. This is a volcanic rock flow, basically, that has erupted into an island that is now growing plants. So they're basically, scientists are able to just watch this remote island go through that primary succession. And a lot of times, I think we may have talked about this a little bit. I don't remember how birds, they'll eat seeds. Like if they're on, say, like the mainland Europe, they'll eat seeds when they're foraging, doing their usual thing. But then when they migrate and they travel to other places, they'll see like an island like this, and they'll stop over. And when they eat things like fruits or nuts, the seeds don't always digest. And this will allow the seeds, and as birds do what birds do, they poop everywhere. These seeds that are still alive will then get into the soil on this new island and have started to germinate. And they've found about 78 vascular plant species.
Which makes you kind of skip the initial steps of primary succession, where you get the mosses and the bryophytes.
I'm sure there were some of that because that's how the soil base is typically formed.
Right.
But also, typically, volcanic soil is very rich in nutrients anyway.
Mm-hmm.
But these are types of plants that lack that sort of long-distance seed dispersal, which is really cool. That's what these. Go ahead.
I think the coolest part of this is that we're getting to see this firsthand on how primary succession actually happens and things like that. Because like most of the time you just theorize and say, "Oh, this has to be the way it comes," because it just makes the most sense. But now you're actually seeing it like on a brand new island.
Yeah. So that's pretty neat.
Do you have anything else to add, Alex?
I do not. It's just how cool we're able to really see this firsthand, like within like something, not just like we can write it down, like recorded history. Like this is like they can take pictures of it, like reliable pictures, and they have seen how this has changed. So that is cool that we actually get to watch this process happen in front of us, not just something that has happened and we're like Tyler said, we just kind of theorize, or we kind of know how it happens, but we don't really watch it happen. So this is pretty neat.
Well, with that being said, we'll move on into our lesson for today. Last time we gave a little overview of amphibians. Today we're going to get into our first grouping of them. So, as we said, there's 3 groups of amphibians: the caecilians, the frogs, and the salamanders. Today we'll be talking about those salamanders because they're kind of the closest thing to like the most basal amphibia at the divergence of tetrapods.
Yeah.
So, Alex, if you want to kick us off, if you want me to.
Go for it, there, guy.
So we're talking Urodela, which is the group known as salamanders. So they're typically lizard-like in appearance, as you can kind of see in Alex's image of.
It is a spotted salamander.
Yep, sure, that one.
Ambystoma maculatum.
So as you lizard-like in appearance means they have a longer tail, kind of stout bodies with stout legs, and a blunt snout. All 10 families of salamander are grouped into this group Urodela. They have the highest diversity in North America, although they're found in Eurasia as well as South America. They rely on cold, damp habitats, mostly around water, although there are quite a few troglodytic species. Those are the ones that live in cave regions. They can range from fully aquatic to fully terrestrial as adults. So as a juvenile and larva, they are tadpoles, like frogs, and as they metamorphose into their adult forms, that's when they kind of become either fully terrestrial, like I'd assume the spotted salamander there is. Those are the ones you kind of find like under the rocks and stuff when you're hiking.
I believe so. Yeah, here I got an even better picture of Urodela.
Yeah, there you go. We got an axolotl in there, a mud puppy, a hellbender.
Looks like a fire salamander. Yeah.
Yeah. These are all North American species of salamander. They're one of the things that is most beneficial to humans is that they're able to regenerate limbs and vital organs. You might ask, why is this beneficial to humans? Because humans are trying to reverse engineer that mechanism into us and see if there's a way that we can use modern medicine to do that same thing. We have some members, the powerful neurotoxin known as the tetrodotoxin. But they have that aposematism.
There you go.
Yep. Which we talked about a couple weeks ago in our Ecology Encyclopedia, and that's kind of like what amphibians and other animals use to like warn, hey, don't eat me. I'm dangerous. I'm toxic. Other members have camouflage to avoid predators, so they really only go one of 2 routes. They use their aposematism to like warn people that they're dangerous, or they're really dull colored to camouflage in to where they're at to their surroundings.
Yeah, typically pretty well camouflaged at that. A lot of browns and greens, like I said, those real fully terrestrial adults around us in our area, like that. We're in kind of the northern part of Appalachia.
Yeah, like
Eastern US.
salamanders.
Yeah, you can find a lot of them like turning over like rotting logs and like under the leaf litter, especially after it's rained, because they like those real damp places, and typically like rotting logs hold a lot of moisture. So if you pick them up in the woods, sometimes you'll find salamanders under them.
Most species use their sight for hunting primarily, and are well adapted for hunting at night. Other members have reduced eyes due to being troglodytic species. Things like cave salamanders, they don't exactly need to see. They'll rely more on electroreception and scent. The fully terrestrial species, though, have flat lenses to increase the range of their sight and can see into the ultraviolet range. So the flatter lenses allows you to see further. I don't know exactly the science behind that.
I would guess so. As opposed to like overly rounded lenses, may help focus it a little better.
And that'll bring us into our family for today?
Yes, our family is the family Cryotobranchoideae.
My bad. Not family. It's not a family.
Not a
It's a
family.
suborder.
Oh, sorry, a suborder. I have a pictor all ready to rock and roll. Bingo.
There you
So
go.
our subfamily Cryotobranchoideae, these are the primitive salamanders. It contains two groups, which is Cryptobranchidae, which holds the giant salamanders like the Hellbender, the Hinobidae, and Hinobidae. That's the other subgroup, which is the Asian salamanders.
Those are the families. The
Yes.
Hinobidae and the Cryptobranchidae.
Yes. So the giant salamanders are typically obligate paedomorphs, which means they retain juvenile characteristics into adulthood, while the Asian salamanders are fully metamorphic. So retaining those juvenile characteristics, in some cases that will mean they actually still have gills outside of the body. Rather than typically, most amphibians will actually take in their oxygen by absorbing it through the water through their skin. But some of the juveniles, as they're tadpoles, they have gills and they'll retain those gills in some cases. So the family Cryptobranchidae, this does contain the largest living amphibians native to China, Japan, and the eastern United States. The South China giant salamander grows to nearly 6 feet in length, while the Japanese giant salamander reaches about just under 5 feet, about 4 3/4 feet long, so quite large in length. And that does include the tail. And for these species, they tend to be a lot more tail than anything else. But they can live quite a while, up to 50 or over 50 years in captivity, typically nocturnal. And even though they have those big tails, they're typically poor swimmers, even though all the giant salamanders are fully aquatic. And they would much rather walk along the bottom of the streams that they live in. Typically, they live in
They live in like mountain streams, which is like well oxygenated.
Yes, very well oxygenated, more mountainous streams. And a lot of them will have large folds of skin along the body, which increases that surface area, allowing for a better oxygen absorption. The same way like gills have a lot of folding. Speaking of, they will lack gills as adults, and also have fairly poorly developed lungs, which is why they're fully aquatic. They rely very heavily on that absorption through the skin. They typically have poor eyesight with small eyes, which kind of makes sense. So they live on the bottom where it's a little muddy.
They're ambush predators
under rocks, too. So they're typically more ambush predators. And they are predators. They'll eat small fish, crayfish, like invertebrates.
Other amphibians.
Other amphibians. I'm sure the giant salamanders are even able to eat some of the really big salamanders are able to eat larger prey as well. There are 6 members in the 2 genera. There's the genus Andreas, which contains 5 species. Those are the Asian giant salamanders, and the genus Cryptobranchus, which has 1 species, which is the Eastern Hellbender, native to our region of the United States, especially in Appalachia. They're fairly abundant.
That'll move us into our second family for the day, our last family for the day. It's going to be a real quick one for you guys. We're going to talk about Hypnobidae. These are the primitive salamanders that are found throughout Asia. Nearly half of all described hinobids are from Japan. They use external fertilization, focusing on egg sacs rather than individual females during breeding. And the females lay 2 egg sacs per season, containing about up to 70 eggs. So the females will lay their egg sac, and then the male will just come along and lay its spermatophore onto the egg sac. Most of them have well-developed lungs, although a few have reduced lungs or no lungs at all. And there are 100 members between the 9 genera. So we have the genus Paradactylodon, which has 2 members. These are the East Asian mountain salamanders. They're found in like Persia, Afghanistan, Pakistan, the Middle East region. We have Batrachuparus, which has 5 members. And these are the Chinese stream salamanders. Hynobius, which has 60 members. This is the largest group by far. Those are the Asian salamanders, mostly found in Japan and China. Liua has 2 members, and they're known as the Wushan salamanders. And Pachyhinobius has 1 member, that is the stout salamander. And they're pretty goofy looking if you find a picture, Alex.
They're goofy looking.
Pseudohynobius has 6 members. They don't really have a group name. We have Rhinodon, which is the Semichensk salamander. Salamandrella has 2 members, and those are the Siberian salamanders. They're goofy looking.
They are goofy looking.
Because they're really thick bodied and they got these little stubby legs.
Yeah, and a real flat face.
Yeah, a really blunt head. And then Onychodactylus has 13 members, and that is the clawed salamander. So one thing to note though is that Onychodactylus, it's in that same family Hinobidae, but it's in a separate subfamily.
Okay.
Within the group. And that's all we have for today's lesson.
Yeah, pretty simple. I think are we doing more salamanders next week, or is this?
Yeah. So next week we'll finish up our salamander talk. We have 2 more subgroups to talk about: the advanced salamanders and the sirens.
Okay.
And the sirens would be like the mud puppy.
Okay.
And that'll do it for today. Actually, we have our most wanted for today, Alex. What do we got?
Yeah. Yeah, we're getting ahead of ourselves. So our most wanted for today is the alpine newt. Now this is native to continental Europe, but has been introduced to areas such as Great Britain and New Zealand. They're relatively small. Let me snag a picture here.
I got you.
Okay, I got one coming up here if it wants to load for me. You got the same picture I was getting. Fantastic. So these guys are, as I said, native to continental Europe, introduced to Great Britain and New Zealand. You can see they have that very dark gray blue color on the back and sides, and they have a very orange belly and throat. But the males are typically brighter, more conspicuously colored than the females, especially during the breeding season, which you can see 2 males here during the breeding season. That's why they're so very colorful. As I said, relatively small. Adults measure up to about 12 centimeters or just under 5 inches. They are, as I said, being kind of they're not so much a invasive as much as just an introduced species, because I didn't want to get into too many of the real good invasive amphibians with our just today. We'll save a couple of the real good ones for later, but they are our least concerned. But in their kind of local areas, there are some areas that they have locally gone extinct. So it's kind of a catch-22. The reason why it's more of a concern for the introduced areas is because they transmit diseases to native amphibians, and it is actively being eradicated in New Zealand for that reason, to try to save the introduced or the native populations of amphibians from these potential new diseases. One of these is called the ranavirus, which is pretty deadly virus to amphibians.
Yeah,
as
they
well
also
as reptiles.
spread chytrid.
Yes, they can also spread the chytrid fungus, which I believe we've talked about, and it is real bad.
Mm-hmm. I think we talked about it last week.
Yeah, I believe so. But that's the biggest thing, is just they're not so much invasive as much just introduced and kind of unwanted organism in those introduced areas, carrying those diseases, especially the chytrid fungus, which is a real problem, as we've talked about, for the amphibians. But that is all I have on the alpine newt. It is Mesotriton elepstris. So this will be a newt I think we'll talk about next week. Yes.
That'll move us on into our fucking amazing species for the week. It's been a day.
It has been a day.
Today we're talking about the Eastern Hellbender.
Yes, sir.
A favorite of the show.
Absolutely.
Cryptobranchus alleganiensis. Imagine that. They're like ugly, but the like adorable ugly.
Yes, gotcha. Hold on, my computer's being a little goofy right now. There we go. Look at that guy.
The eyeballs are the best part because they're so like pinpoint.
They're so goofy.
So the IUCN lists the Eastern Hellbender as vulnerable, which is not like the worst thing in the world. They're still decreasing, but they're found in water systems ranging from like southern New York, around Albany, all the way down to Tennessee, and even into Mississippi, and maybe into Alabama and in the Chesapeake Bay region. Or
it's looking like some of those the real far south, like near Alabama and Mississippi, as well as that Chesapeake. I forget what is that, the Susquehanna, I think, in that area, in like that eastern Pennsylvania, Maryland area. It may be that they're possibly extinct, but they are found, as I said, they're found a lot in the Appalachian region of the eastern United States, and then over into the Ozarks in Missouri, and a little bit into Arkansas. As we said, those higher elevation areas that have those real mountainous streams. I don't think I know I haven't had the pleasure of finding one. I know they are supposed to be able to be found actually not too terribly far from us. There's a stream system about 45 minutes east of us that it's said that they have been found in the past.
Field trip,
yes. Can't touch them though.
No. But their list is vulnerable because they've seen significant decline, about 30 to 50% over the past 2 generations, which would be 30 years, assuming the generation length is 10 years.
Yeah,
and
as
that's
we said,
mostly...
they do, all these giant salamanders do live a good bit.
Yeah. And that's mostly due to disease and habitat loss and other degradation.
Runoff, because Appalachia is very well known for its mining.
Yes.
And as well as some logging and other human-related things that have caused issues with the stream ecosystems.
So there's a lot of secure subpopulations, although the overall population is in decline, and that's mostly due to habitat modification. There have been 570 occurrences of the subspecies Cryptobranchus alleganiensis. 68 have been, 12% have been extirpated or functionally extirpated. 69% remain extant, and 19% are of unknown status. And then of that, 57 of those populations are declining. 35 are healthy, and 301 have an unknown trend. So it's kind of up in the air on what the population's actually doing as a whole. Just because they're so secretive, and they live in those high mountain streams that no one really likes to do any population polling of.
Yeah, and it said that subspecies, the Eastern Hellbender, is the alleganiensis, and then, as I said, that Ozark Mountain population is considered its own subspecies of Alleganiensis bishopi. that's where the separation has been. But Tyler, do you want to share some of the great vernacular names for the Eastern Hellbender?
Yeah, where am I finding those at?
I'll share a couple for you, like the snot otter
Oh
or
yeah.
the Allegheny alligator, even though they're salamanders, completely harmless. They don't have any sort of toxin to them or anything. They're
There's
great.
there's a baseball team, like a
The
minor league
lasagna
team
lizard.
there's a minor league baseball team somewhere around where minor league baseball does a whole bunch of alter ego identities for a day or two during the season, and some team rebranded themselves as the Snot Otters for a game or two, and it made me laugh.
Yeah, I found. Here we go. It was. I'll find it for you if it wants to load. In Asheville.
Yes.
It'd be Asheville, I think, Tennessee. Yes. The Snot Otters. It's fantastic. It's a minor league baseball team.
But they are under a wide variety of threats. A lot of commercial and residential housing development, roads and railroads, recreational activities like boating and water skiing and all of that stuff, fly fishing, mining and quarrying because that's huge in Appalachia.
Yes.
They're not the brightest, so they kind of get stuck in some traps occasionally. Dams are a big thing, although a lot of modern dams kind of have like ramps and things for the salamanders to kind of like work their way through the water system.
Yes.
So I've read. As well as just general pollution. Amphibians are, as we know, are very susceptible to pollution because they breathe through their skin. Hopefully I can find some of these. Why don't you tell me the actual species?
And it is the. I'll share this fun little factoid. As Tyler and I both live in Western Pennsylvania, and it is the state amphibian of Pennsylvania, which is a state in the United States. So, just a little little fun fact because I'm just full of useless knowledge up here. It's great.
Specifically of the Hellbender.
Yes. There's a lot of useless knowledge up here. That's just one thing.
Yeah. They are collected for the pet trade. As well as for research specimens. Research specimens make a little bit more sense, but pet trade kind of scares me.
Yeah, a little bit, but they are a federally listed species, so you can't legally own one, I don't think, if you're not like able to prove it's for research.
Give me 1 second. I have a book.
You gotta find it.
I found it.
I knew exactly where it was.
This is my book of American animals, and there is a bit on the Hellbender.
Oh man!
I shall read it for the class.
Yes.
Hellbenders are among the largest salamanders in the Americas and one of the 3 giant salamanders in the world. These monstrous and heavy-set amphibians spend their entire lives on the beds of rivers and streams. Hellbenders are nocturnal and spend the day sheltering under rocks. At night, the animals become more active, but generally lurk in crevices while waiting for prey. Giant salamanders lose their gills as they change from larvae into adults. They absorb most of their oxygen through their wrinkly skin, but will sometimes rise to the surface to take gulps of air into their small lungs. Hellbenders breed in late summer. A male digs a hole under a rock and will only allow females that are still carrying eggs into his hole. Several females may lay their eggs in a single male's hole before he fertilizes them with a cloud of sperm. The male guards them for 3 months until the young hatch out.
Neat.
There you go. That's the most
crash course.
That's the most facts I've given about amazing species in forever.
I know. Well, this is one that we both carry near and dear to our hearts. So,
but that's not all we have for you guys. We have our final segment of the day. Alex, what are we talking about in our ecology encyclopedia?
We are talking about hibernation. So it is getting to the end of fall. Winter is approaching in the northern hemisphere. So now I figured this is something that's appropriate to talk about, especially since we're getting into amphibians, because as you can see on here, we have the wood frog. It is just now for your ectotherms, so your amphibians and reptiles, animals that rely on exterior heat sources like heat from the sun to kind of power their metabolism a little bit. Their hibernation's a little different than like mammals. Especially, I mean, obviously we commonly think of bears that hibernate, but as you can see, this is just a list of 11 other animals, like bats, skunks, groundhogs, I believe squirrels as well will hibernate. So like a lot of rodents. So there's actually two different types, or a couple different types of what we would call hibernation, and then what the amphibians do is a little different. I will talk about it, but just a quick overview. What is hibernation? It is a state of reduced metabolic activity in some species. This typically in the wintertime when food is not available and it's very cold. Animals will lower their body temperature, slow their breathing, slow their heart rate, thus slowing their metabolism. That allows them to basically sleep through the winter. This is sometimes called overwintering, which and this is a pretty useful kind of evolutionary trait, because like that wintertime I said, the food is not as abundant, it's cold, so it requires a lot more energy to stay warm. So these animals will put on a lot of fat through the summer months, so that way when it comes to hibernation, they will just rely on those fat stores to get them through the winter. Now there's as I said, there's a couple different types of hibernation. You have like deep hibernation, like rodents, and even like bats, where they pretty much shut the whole way down and just sleep through the winter. But other animals, like I said, like bears, they do. It's more of just a state of reduced metabolic activity. It's not quite that full like shutdown that a lot of the rodents do. Like in our area, black bears, they will give birth during that hibernation period, like over the winter months, while their offspring are still small, and they will suckle on the mother and get that milk kind of while they're in their den, that kind of safe space, so that until they can put on some fat and grow a little bit. By the time spring comes, they're able to move around pretty well, and they have a bit of a jump start for the spring and summer. There is a kind of alternate version of this for the summer months called estivation, AES estivation, where I'm sure this typically happens in areas that are more like arid, like desert environments. You could almost more call it like that summer, like the dry season is typically, when you think about this, areas, like I said, desert, dry environments, where it's the opposite, where that food isn't as available during the summer when it's so dry. So rather than pretty much get cooked alive and starve, these animals will find a nice, cool, safe place and kind of hibernate, quote unquote, to until it gets to the rainy season again. And I said those deep hibernators, these are animals that are there are animals that are obligate hibernators, like a lot of rodents, like ground squirrels, hedgehogs, a lot of the monotremes and marsupials, where they pretty much have to go into this hibernation state during the winter time. And there's even the Arctic ground squirrel will get its body temperature as low as negative 2.9 Celsius or 26.8 Fahrenheit, so very cold comparatively. There are only one species of primate, that fat-tailed dwarf lemur, is the only primate known to hibernate. And of course, bears. Even some birds were believed to hibernate, but and it said that the common poor will is the only one that is known to actually hibernate. A lot of them, it's called a torpor, which is basically just a period of decreased activity. In the where's it at here? In the amphibians, this is typically called. I had it here. Let me find it again. here we go. It's typically called a brumation, BRU, brumation, where it's like that decreased metabolic activity. It's not the same as hibernation because they can't actively regulate their body temperature or their metabolism. So this is more of just a dormancy in those cold periods, as well as periods of low oxygen availability. Say if it's like in the some summer months where it gets real like stream beds will dry up, these organisms will go into that state of brumation where they're just kind of chilling until they get the water back. So they're animals that can do this, like the wood frog, red-eared sliders, box turtles, even goldfish can do this.
But wood frog's the one that like freeze in the winter and then like thaw out and live still.
Yes, they actually can. I think there are a couple different species that can do this, but yeah, so that what they will do is they'll accumulate, instead of like accumulating the fat in their bodies, they'll accumulate urea, which is a nitrogen product. It's typically a waste product. So it's urea, sounds like urine, but it'll accumulate in the tissues, acting almost like an antifreeze, as well as they'll store a lot of glycogen in their liver, instead of like the fat that you would usually think of. And this typically happens in the wood frog species further north, near the Arctic Circle, like the Alaskan wood frog. But yes, they can survive as long as no more than about 65 to 70% of their total body water will freeze. So they've been known to survive temperatures as low as negative 35 degrees Celsius or negative 31 degrees Fahrenheit for up to 120 days in a row. That was in the Japanese tree frog. I'm sorry, so a different species of frog, but one that's also very well cold adapted. The wood frog, it's actually even up to 193 plus or minus about 11 days straight.
So over 200 days.
Yeah, so roughly 200 days. But they can only their temperature range is only goes to about as low as on average negative 6.3 Celsius or 20.7 Fahrenheit.
Only.
But that average minimum range is about is actually even lower, negative 14.6 plus or minus about 3 degrees Celsius, which is about 6 plus or minus 5 degrees Fahrenheit. So very well cold adapted. That's what kind of the whole goal of hibernation is in those very cold, food poor months. These animals will store up fat during the warm, food rich months and use that fat and energy to survive over the winter. And like bumblebees or other bees, why they will stay, at least like the colony bees will stay in the hives, and that's what their honey stores are for. Now, before anyone gets a little crazy, that we collect honey, they will produce an excess of honey. So typically, anyone who farms honey, those bee boxes, they'll have like 2 or 3 tiers. The bottom tier, or at least the bottom 2 tiers, typically are what they leave for the bees, which is more than enough for them. They're very small animals; they don't need to eat a ton, especially when they're not moving a lot. Then they'll just collect from that top box. So before you throw a fit. But that is all I have on hibernation today. It's a cool subject, kind of something I think was pretty topical as we get into the hibernation months. And I'm sure in a lot of, especially in the far north, there's a lot of animals that have already started.
True.
If not, have been.
That's all we have for today's episode of Life the Complete Story.
Yes, sir.
I've been Tyler. That's been Alex. I already said at the beginning of the show, but make sure to follow us on Instagram at Life Complete Story, on TikTok at Life Complete Story, Facebook at Life the Complete Story, YouTube, Spotify, everywhere you get your playlists at Life the Complete Story, and then send us an email at lifethecompletestory@gmail.com for any questions, concerns, things of that nature that you want us to discuss on the show. Anything else, Alex?
That is all. And as we always say, keep on learning, learn something new. You'll never know what you find interesting. But I've been Alex, and that has been Tyler. And thank you for joining us on another episode of Life, the Complete Story. We'll see you next week.